then 0. Hence this is equation 1, right? This is our equation 1, y is equal to 1 minus x square. Hence the equation 1 of the curve increases in minus 1 to 0, because when x is between minus 1 to 0, dy by dx is greater than 0. So the graph of this function increases in minus 1 to 0 and decreases in 0 to 1. Clearly, now this is only the talking about the for equation 1, where equation 1 is 1 minus x square. In that case, x is between minus 1 to 1. Okay, so the graph of this function is increases in minus 1 to 0 and decreases in 0 to 1. Now also we are talking about the graph equation 2, that is y is equal to x square minus 1. Now y is equal to x square minus 1. In that case, when x is a bit less than minus 1 and x is greater than 1, right? So and the dy by dx is 2x in that case. Now when dy by dx is 2x, the dy by dx is less than 0 in minus infinite to minus 1, and dy by dx is greater than 0 in 1 to infinite. Okay, 1 to infinite. So clearly the graph of this function is increases in 1 to infinite and decreases in minus infinite to minus 1. So the equation 2 decreases, the curve decreases when x is less than minus 1, right? Because in minus infinite to minus 1, the dy by dx is less than 0. So the curve decreases when x is less than minus 1 and increases when x is greater than 1. Okay, so now here we observe some of the thing about the graph, that again I repeat that the graph of this function is first of all symmetric about the y-axis. The graph of this function is does not passing through the origin. The intersection of the x-axis and y-axis of this graph is, the points are minus 1 0, 1 0 and 0 1. So minus 1 0 and 1 0 are the points of x-axis, right, and 0 1 are the point of y-axis. So the graph of this function is passing through the points 0 1, minus 1 0 and 1 0. And when we are talking about increasing and decreasing function, the graph of this function is, you can see the decreases in x less than minus 1, increases when x greater than 1, and between minus 1 to 1 the graph is increasing from minus 1 to 0 and the graph is decreasing from 0 to 1. So let's try to draw of this graph. You can see the graph of this function is similarly like this. The graph of this function is roughly, if we can draw, the graph of this function is 0 1. This is a graph of y is equal to modulus of x square minus 1. This is the point minus 1 0, this is the point 1 0, this is x axis, this is y axis. Now you can see the graph of this function is symmetrical about the y axis. This is our y axis. So clearly you can observe that the graph of this function is symmetrical about the y-axis, right? Also this graph is passing through the points 0 1, minus 1 0 and 1 0. Okay, now also the graph of this function is this is origin. The graph of this function is increasing when x is belongs to minus 1 to 0. Okay, the graph of this function is increasing. Clearly you can see the graph of this function is decreasing when x is between 0 to 1. The graph of this function is increasing when x is 1 to 0, right? 1 to infinite, that means when x is greater than 1, the graph of this function is increasing. Okay, and the graph of this function is decreasing when x is less than minus 1, because you can see at point minus 1 the value of this graph is 0, right? When x is minus 2, you can see the value of graph is increasing, right? So when x is become a smaller and smaller, the value of function, the value of graph is become increasing. So that's why when x is less than minus 1, the graph is basically decreasing. Okay, so here we sketch a graph y is equal to modulus of x square y minus 1, and also we can say something about this graph, that symmetrical about y axis, does not passing through the origin, it intersects it on x axis on minus 1 to 0 and 1 to 0 1 0, minus 1 0 and 1 0, also intersect at y axis is 0 1, right? Increasing in minus 1 to 0 and decreasing in 0 to 1 when x is belongs to 0 to 1, increasing on 1 to infinite, and also decreasing from when x is less than minus 1. So here we complete the solution of this question. Sketch the graph of y is equal to modulus of x square minus 1. The next question. Question 3a, first part. Obtain reduction formula that expresses the integration log x raised to n dx in terms of an integral of a lower power of log x. So here we have to use integration by parts. Call it in is equal to integration log x raised to n dx. Now we know that integration by parts, integration uv, that is equal to u integration v dx minus integration u dash. U dash means the derivative of u, this is u, integration v dx dx. So here log x raised to n, we are consider log x raised to n is our u, and 1 we can also write down 1 into 1, so 1 is our v. So integrating by parts, we have in is equal to, now apply this formula, log x raised to n as it is, as here u is as it is, integration v, that means integration 1 with respect to x, so that is x, minus integration u dash, integration u dash, so that is n log x raised to n minus 1. Also we have to derivative of log x, so that is 1 upon x, and this is integration v, where v is 1, So integration v is x. So finally we get this term dx. Now this x will be cancelled out. So this equal to x log x raised to n minus n is a constant. So n can be outside from the integration. Integration log x raised to n minus 1 dx. Now if in is equal to integration log x raised to n dx, so integration log x raised to n minus 1, we can say this is in minus 1. So finally we get in is equal to x log x raised to n minus n minus 1. Okay, so this is our required formula, right? Next question. Question 3a, second part. Find dy by dx if y is equal to integration x to 5 3t sin t dt. So here y is equal to integration x to 5 3t sin t dt. Now this can be expressed as minus 5 to x 3t sin t dt minus, right, because integration from x to 5, that can, if we want to change the limit, right, we have to put down here minus 1. So minus 5 to x 3t sin t dt, and this equal to, now the dy by dx, the dy by dx is minus d by dx of integration 5 to x 3t sin t dt. Now using fundamental theorem of calculus, this equal to minus, because this is the derivative, this is integration from 5 to x, so directly we can write down the value of this term is minus 3x sin x, right, by the fundamental theorem of calculus. If you want to write down the reason for that, by the fundamental theorem of calculus. So here is the reason for that, dy by dx is minus 3x sin x. Okay, so we complete the solution of this question paper up to this question. Thank you. Have a nice day.